In this recording, sizobe siphendula nangu question 2, which is a question on ama-Newton's laws. In the description box, ngicela ucheck uzothola ama-links for other recordings engwayenzile for this question paper. Now, la question 2, a man faces difficulty while swimming in a dam. During the rescue operation, an inflated tube attached to a helicopter by a rope is dropped from the helicopter. Mawuthatha ukubheka le diagram yethu, everything abayi-explainile lana. So this is the helicopter, it drop a tube, and then the tube and the man form a combination. So the man is holding onto the tube so that anga sink inside the dam, into the dam, and then the helicopter starts dragging the man in this direction. Then the man of mass 70 kilogram holds onto the inflated tube of mass 4 kilogram while the helicopter is flying horizontally at a constant speed. There's a reason for this emphasis, constant speed, which is what we discuss at a later stage. An average frictional force of 300 newtons is exerted on the man tube combination while they are dragged horizontally along the surface of the water by the helicopter. The rope makes an angle of 50 degrees with the surface of the water as shown in the diagram below. Assume that the rope is inextensible and massless and the water of the dam does not flow. So the dam does not flow, there's no movement in Lamans. Lamans are stationary. The only thing moving la pemanzin, it's the man tube combination in this direction. Hey, pasipaleli short story la. Okay. 2.1. State Newton's first law in words. Newton's first law, uthi a body will remain in a state of rest or motion at constant velocity unless a non-zero net force acts on it. 2.2. Draw a free body diagram of the man tube combination while they are being dragged. Okay, it's for a free body diagram. So the free body diagram la. Okay. Ama laws, right? Ama laws, especially like paper 1, physics paper 1. Kwamele wazi first law, second law, okay, bese no third law, right? Lama laws lawa kwamele ukwazi ukwa define ngoba bheka 2 marks, this is 3 marks, I mean. Ama marks wamahala lawa, so kwamele ama laws ukwazi ukwa define. Going into paper 2 as well. What's this man? Lichetlia's law, and the other laws man. Kwamele ukwazi ukwa define. Every chapter, lama chapters lawa lakunama laws khona. Make sure ukuthi uyawamastara lawo ma laws, or let me say uyawazi ukwa define. Ngoba bayathanda ukwabuza, so ama marks wakamahala ke lawo. Another free mark ilaguma free body diagrams. 2 marks yakho, this 4 marks is also yours as well. So ama free body diagrams, this is the free body diagram, so you draw la, right? Now to draw free body diagram yakho, make sure ukuthi uyawa calculate nama forces owafakile kuma free body diagrams wakho. Yes, if it's 4 marks, it means that una 4 yama forces okwamele wa draw ku free body diagram yakho. So sifuna the free body diagram for the man tube combination. So sina 4, starting at the easiest ones. Normal force. The normal force is between the man tube combination and nani naman. So amanza exert an upward force on the man tube combination. The gravitational force, it's the weight of the man and the tube. So they are going in the downward direction due to their own weight. So na 2 marks again manje. And then ungakhohlwa kune tension futhi, the tensional force. Ile force sithola kule rope attached to the helicopter, and then kuba nani the frictional force. So in total una 4 yama forces acting on the main tube combination. So 4 marks our counter 1 2 3 4. Okay, 4 marks, yeah, definitely, yeah. So na 6 marks already. So lana ungalahla ama marks ke. Do not lose ama marks ku free body diagrams and defining ama force ama laws. 2.3 la ku 2.3 bathi let us calculate the tension in the rope. We want to calculate the tension in the rope. Now lana, okay, first things first, the main tube combination move in which direction? Horizontally to the left. Yes, to the left, to the left. So now so apply ama Newton's laws. You need to identify direction. If the object move up or down, left or right, izokunceda ukuthi set up a equation yakho ke. Yabona? So in order to calculate the tension in the rope, we have to look at the motion of the main tube combination. So now since iloganji, the main tube combination is moving to the left horizontal, so it means that we only pay attention to only ama forces in the horizontal plane. Ama forces lawa in the horizontal plane. Ama forces lawa in the horizontal plane kuphela, these ones, right? See now, 1, which is the frictional force, and remember this T, the tension yethu ineloganje in our components because of its acting at an angle. So the horizontal component Tx, the horizontal component Tx is the force from the tension A actile on the horizontal plane. Yes, there's tension, but only the horizontal component of the tension force is acting. So we have two gamma forces acting in the horizontal plane with Tx no F. Yes, with Tx no F. I only pay attention to these two forces ngoba the main tube combination is moving in the horizontal plane. And then now T ke. Yabona no T sigavela. So we have to calculate for bani for T. Yes? So we only calculate for T. But this can cause no Ty as well, the vertical component. But the vertical component has no use for us in this calculation. We only pay attention to the horizontal movement. But that's where there is movement. Now, F net is equal to MA. See, apply Newton's law. Second, okay, it's not second law. Ngoba there's a constant speed. Constant speed is what we are dealing with Newton's first law, and F net is equal to 0. So therefore it means that we only have F net in the horizontal plane. F net now it's Tx. If I choose to the right as positive, if I mean to the left as positive, if I choose now Newton's laws, now vectors, you need to choose a direction. So I'm choosing to the left as positive, hence Tx aba positive, and the frictional force iba what? Iba negative. So the F net is equal to 0 because of this is Newton's first law. How do I know? It's because of there's a constant speed. Pay attention to its definition ga Newton's first law. Now we substitute again. Tx is T cos 50 degrees minus 300 newtons. But pile the frictional force with 300. Therefore, we calculate for T in transposal with 300 and divide both sides by cos 50 degrees. With T over equal to 300 over cos 50 degrees. Atini calculate. Okay, calculator. 300 divided by cos 50 degrees is equal to 466.72 newtons. So now I answer it again. So this is the tension in the rope. With 2.4, how will the answer to question 2.3, change if the helicopter accelerates while dragging the man. Now, but is the helicopter is moving at a constant speed. Now, sebabuya ke manje. Basupose ukuthi tension yethu, how will the answer to 2.3, the tension, change if the helicopter accelerates while dragging the man? The frictional force and the angle between the rope and the surface of the water remain the same. So friction in the opposite direction, and then the angle, they remain, the frictional force, okay, these two remain constant. Choose from only increases, decreases, or no change. Give a reason for the answer. Mina ngithi izo increase tension. The tension will increase. It increases. Why do I say that? Now, if we are accelerator, it means it's no longer Newton's first law, it's Newton's second law. Sesibanani ne friction ke manje. So we no longer have u0 la. Now it becomes a number. So nang transpose alo 300 yofika ngale abe ubani more than 300. And then if it's more than 300, like it means uT uzoba greater than ubani uT u 466. So therefore it's because of F net is greater than 0. It's greater than 0. That's the reason why. Now 2.4, there's a second part of the question which is why you answer now much. But first I think erase la. Alright, 2.5, the last question again. Now 2.5. Alright, like 2.5, but in another rescue operation, the inflated tube of mass 4 kilograms is dropped from the stationary helicopter and it strikes the water at a speed of 16 meters per second. The tube sinks vertically downwards into the water to a depth of 0.8 meters and then rises to the surface. The rope hangs loosely as shown, like the sketch. Yes. Ay, lana ngat pasipha ma-essay, ama-statements angaga mara. Bese ke bathi 2.5, calculate the magnitude of the average upward force exerted on the inflated tube while it is sinking. Assume that the average upward force is constant for the motion. Is constant for the motion. Is over constant for the motion, the upward force. Okay. Now, lana senze so. Now amanzi la. Right? Now a tube yethu. Let's say the tube is sort of like a box nyana, so. Sort of like a box nyana. Now ifika le tube izo strike la manzi ngo 16 meters per second. Bese yenzani ingena emanzini. Boom. Yangena ke. Mayingena, it's still going down, right? But in the tube sinks vertically downwards into the water to a depth of bese itna seyifike la good depth of 0.8 meters. What happens again? And then rises to the surface again. Then iwela phezulu, right? Ya drop a boom. Na ifika la at 0.8 meters. Yenzani, it starts rising again so that the man can catch iloganji tube yakhe and probably save his life or something. And then bheka ke manje yabona le tube le, while it was dropping, it was experiencing an upward force F. Okay, let's call the upward force F. Na drop le tube lena iwela kuphi emanzini. So nayiwele emanzini kanje, so what happens, la manzi the friction due to water izozama ukustoppa the tube from going deeper emanzini, right? So this is the force esifuna ukuyi calculator, but le tube ya dropper due to its own weight, ubani Fg. Therefore the sinking tube is dropping due to its own weight, Fg. Angit? Due to Fg. Now bheka, this is going to be plus Fg minus F if I choose the downward direction as positive. yes, and le tube lena izodropha the F net between FG now the upward force is going to be equal to MA. F net is over equal to MA. And the tube lel drop la lizobe li accelerator. Ngoba ekuqaleni it was doing what? It was on free fall. But nase ifike emanzini iyofikisa accelerator. But accelerator kwakhona look accelerator kwalelo kanje kwale tube leli kwamele li stop the acceleration is stopwa yini ile friction yani yamanzi. So we need to calculate the acceleration. We all okay, FGs now we can calculate to FG. I have the mass of the iloganje, I have the mass for the tube. Mfuna F in this equation. I have the mass as well. So about we need ubani A. Now if I take out the data abasiphe yona lapha, I have initial velocity of 16 meters per second. Just when the tube it strikes the water at a speed of, so that makes 16 initial velocity to final velocity about 0. Ngoba le tube nalifika la V final is over equal to 0. You stop and then it changes direction and starts going up. Delta y is over equal to positive 0.8. This is the displacement. It's going down, so it means what again? It means now displacement it is over positive. Now, signal data I can calculate the acceleration yami again manje. But I'm going to need a formula. Ngizosebenzisa some equations of motions. In a final velocity, in the initial velocity, I want the acceleration. I also have delta y or delta x. If I acceleration la, all the three values in now. So f final squared is equal to v initial squared plus 2a delta y final 0. So substitute 16 squared plus 2 acceleration unknown delta y is 0.8. So it's 0 lana. What is 16 squared? 16 squared it's 256. 256 plus we are calculator man when's much 0.8 1.6, so it's 1.6a 1.6a, then in transposer uban, so transposer lo 1.6a 256 divide both sides by minus 1.6 minus 1.6. So answer it yoba a negative what? 256 divided by negative 1.6. It's what? It's minus 160 meters per second squared. The acceleration, ungabi surprised, the acceleration yethu nangabe iba negative. We chose down as positive ngoba the tube is going inside amanzi and it's decelerating, so hence acceleration yethu aba a negative because there's deceleration. Now sesizalana ke FG it's mass times gravitational acceleration, so it's 4 times plus 9.8. Acceleration is always acting downward. Minus F equal to mass 4. Acceleration it's minus 160. And then I transpose minus F kusala yena. What is 4 times minus 160? It's equal to negative 640 minus 4 times 9.8. This is equal to 39.2. Now izoba negative ngoba nangi transpose ayizanga liba negative. So what is our final answer ke la? Sibone minus 640 minus 39.2. This is equal to 679.20. So F uzoba equal to 679.20 newtons. 20 newtons. So now F is equal to this value, and the IBA okay, upward is over upward. This one is going to be upward. So yeah, the average upward force is constant for the yield force specifuna. So yeah, this is the upward force applied by amanzi when the tube is sinking. So our question 2 iphelela lana, guys. I hope we enjoy, like I hope we told some value out of this. Now we told some value. We again angishiyeli like lapho, ushare nabangani bakho, usubscribe nangabe new to this channel, and in the description box uzothola ama links for amanye ama recordings. Now we interested, wa check asikhulume in the comment section nangabe unama questions.